in today's lecture, we will continue from where we left in the last lecture, and then we will also learn some new techniques of finding arc length, finding surface area of 3D diagrams, and finding volume of 3D diagrams. So, first we will solve some problems that were left in the last lecture, and then we will go on to learn these new techniques. Okay. Can we start? So, there is a curve here, mod of y equal to 4x minus x square, and we want to find the area bounded by this curve. So, this curve could be open-ended curve or closed curve, but we have to draw the graph and observe where exactly the area is bounded, because area must be bounded by the curve itself. So, there must be a closed loop somewhere in the diagram. Okay. So, we have to draw the diagram first and then go for the integration. So, as we discussed in the last lecture also, there could be some techniques, there could be some books which talk about blind integration, but do not do that. Directly go for the graph first and then go for the area. So, here if we go by our curve sketching algorithm, what is the first step that we need to check here? First step is to check if there is symmetry or not. So, if I place minus y in place of y, here equation remains same because there is mod on y. So, hence the graph is symmetric about x axis. Now, if I replace x with minus x, equation will change. So, hence there is no symmetry about y axis, but there is symmetry about x axis. So, that means if I draw the graph which is above x axis, I can reflect it to get the graph below x axis also. Okay. So, that means I only have to take one case which is y greater than 0 and draw the graph for this. So, y greater than 0 means we are talking about above x axis. So, let us say this is our x axis, and now if y is greater than 0, equation becomes y equal to 4x minus x square. Now, before we proceed, there is also one more important thing that you have to notice, because LHS is already a non-negative number. So, RHS must be non-negative. So, that means if I solve this inequality 4x minus x square greater than equal to 0, what is the region that I will get? Here I will get 4 minus x into x greater than equal to 0, which means x must be between 0 and 4. So, this is the domain that I am getting for the required condition. What is the condition? That LHS is non-negative, so RHS also must be non-negative. Even otherwise, let us say you did not think about this and you blindly went for the graph of this function. Now, if you look at this, this is quadratic in x, so it must be a downward parabola because coefficient of x square is negative. Now, what are the roots here? Roots are 0 and 4. So, let us say this is the 0 root and this is the 4, and it is a downward parabola. So, the graph is going to be somewhat like this. It is a downward parabola, but because we have taken only y greater than 0, that means above x axis. So, the parts of the graph which are below x axis must be deleted completely. So, this is the graph that we get for y greater than 0. So, even if you do not do this and even if you have blindly approached the graph, then you must be getting the same graph by this idea. Okay. So, now we got the graph which is above x axis. So, we know that there is symmetry. So, we can draw the complete graph by drawing the other part also. Now, this becomes our final graph, and we want to find the area enclosed or bounded by this graph. This is a closed graph. So, area is bounded, area is enclosed, we can go for the integration. Now, while integrating, because there is symmetry, if we just find the area which is above x axis and if we double it, we will get the required area. Okay. So, how do we approach this problem? We approach this as area is equal to 2 into integral 0 to 4x minus x square into dx. Okay. That is it, this will give us the area. So, what will be the answer here? So, we have to integrate this. Integral of 4x is 4x square by 2, integral of x square is x cube by 3, limits going from 0 to 4. Now when we put 4 here, we will be getting 4 cube by 2 minus 4 cube by 3. So if I take 4 cube common, so I will get 2 into 4 cube into 1 by 2 minus 1 by 3. You know the value of 1 by 2 minus 1 by 3, it is 1 by 6. So overall value is going to be 4 cube by 3. So this way we can find the area of the loop. Okay. Come on, make a note of this. Okay. Now can we go to the next question? Next question is, find the area bounded by this graph. So here, just like earlier questions that we have discussed in the last lecture, there is inequality involved and also there is modulus involved. So how do we approach this? We approach this with equality first and then we go for the inequality. Now that is first idea. Now second idea is, there is modulus involved, so we have to take one of the cases. Because there is mod, there is going to be symmetry. But here there is not a single x inside mod, there is mod of x minus 2 and here mod of y plus 1. So basically this could be treated as a shifted graph from origin to some other point. So to solve this question, what I will do is, I will take this graph which is shifted to the origin. So basically the center of this graph can be taken as 2 comma minus 1. That is the point where this term becomes 0 and that term, second term also becomes 0. That becomes our center of the graph. So what basically I am doing here is, I am shifting the center to origin. Okay. So this also means that if I shift any diagram anywhere, if the orientation is not changed, if the curvature is not changed, then area will remain same, and because modulus curve when shifted anywhere will not change its area. In fact, any curve when shifted from one point to another point, if it is pure shifting, then area will not change. So here also area will not change. Now handling this equation is actually very easy. So we will solve this and we will say that the area of this curve is also same as the area of that curve. Okay. Now how to go about this? We take the equalities. So there are two cases here. One is mod x plus mod y equal to 1. The other is mod x plus mod y equal to 2. These are the cases of equality. Now how to draw the graphs of these two? We have already seen the cases. Because there is mod on x, it is symmetric about y axis. Because there is mod on y, it is symmetric about x axis. Now because there is double symmetry here, we only draw one case which is in the first quadrant and we reflect it to get the other parts also. So basically we are going to take this case of x greater than 0, y greater than 0. So if we take this case, then our equation becomes x plus y is equal to 2. So what will be the diagram for this condition? The diagram will be having 2 as x intercept and 2 as y intercept, and it will be a line segment. Now we have to reflect it. So reflection about y axis will give us this part and reflection about x axis will give us this part. This is the mod x plus mod y equal to 2 curve. Now we will also draw the other part which is the mod x plus mod y equal to 1. So here also the same case and same analysis. So it is going to give us a diagram like this. Okay. And what is the area that we are interested in? Because here exactly equality is not we are talking about, we need this expression to be less than equal to 2. So that means basically we are talking about the interior portion of this region, this line, and also exterior portion of this, because there it must be greater than equal to 1. So that will give us an area like this. Okay. Now, how do we find this area? If I find the external area and if I subtract the internal area, I will get the required area. And here if we notice, this is 1 unit, this is also 1 unit, this is also 1 unit, this is also 1 unit. So, basically this is going to be a square, but we do not have to apply the square, we can also directly apply the formula of half d1 d2. So, here the area is going to be half into here the entire diagonal from here to here is going to be 4 units. So, it is half into 4 into 4 minus half into 2 into 2. Now, we can just simplify it and get the answer. So, what will be the answer here? 2 will get cancelled, here also 1 2 will get cancelled. So, 8 minus 2 is going to give us 6 units as the area of the diagram. Okay. So, this way we can find the required area here. So, whenever there is modulus involved, we need to understand that there is of course symmetry. So, we have to handle symmetry this way. But here there is also this shifted version of the idea. So, whenever a curve is shifted, area will not change. So, for simplicity you can shift the curve to the origin and solve the question. Okay. Come on, make a note of this. This page also. Okay. Now, we will move on to the next question. This is an interesting question where through inequalities certain curvature and certain area is represented. So, how to go about this? Here if we check, this is one linear inequality, and here if we check, this involves some quadratic forms. We do not know the diagram correctly. To check the diagram, we have to simplify that equation. So, first equation is very simple equation, which is x plus y is less than equal to 6. This is going to be a straight line and there is less than equal to, so it is either below the line or above the line. Because coefficient of y is positive here, so it is definitely below the line. So, this is below the line. We will draw these in the next page. Next, second equation, I am going to simplify this and check if this could be converted into a standard equation or not. So, when I simplify this, when I take everything to LHS and simplify, what do I get? Here there is only one x term, there are two y terms. So, to convert this into a complete square, I will add 9 here and also I will add 9 here. So, this will give us x minus 0 whole square plus y minus 3 whole square less than equal to 3 square. So, this is going to be interior of a circle. Okay. And next, third, what is the third equation? It says y square is less than equal to 8x. So, in general, if we take this curve, it is going to be a parabola y square equal to 8x. But here y square is given as less than 8x. So, for positive values, if y is less than root of 8x, it means we are below the curve. For negative side also, if it is less than, then of course we are above the curve. So, basically we are in the interior portion of this parabola. Okay. We are in the interior portion of this parabola. So, now we have to combine all three of them and draw the diagram. Okay. So, let us draw the diagram here. So, let us say this is our y axis, this is our x axis. One is x plus y must be less than equal to 6. So, let us say there is 6 here and let us say there is 6 here. So, this is the line which represents the first equation. Now, it has to be below the line. So, this is the region that we are talking about. And second, it is a circle having 0, 3 as the center and 3 units as the radius. So, where will be 0, 3? Here there will be 0, 3. And 3 units radius means the circle is going to pass through the origin and also this point. So, that I will draw in red. So, we are going to get a circle like this. Okay. And it must be interior of the circle, and then again parabola. So, this parabola is going to be somewhat like this, because it has to start from origin and it has to go like this. But we do not know where exactly this curve is going to cut the line and circle. So, we have to do some rough work and evaluate if there are any points of intersections, and based on that data we have to draw the graph. That will be the accurate graph. So, let me solve it with the straight line first. So, here I am solving this with the straight line. So, y square is already given as 8x, and from here if I get x, x will be 6 minus y. So, if I put it here, I will get y square equal to 8 into 6 minus y. So, y square plus 8y is equal to 8 into 6. Now, to convert this into perfect square, I just have to add 16 here. So, I will add 16 here also. So, this is going to be 16 into 4, which is going to be 64. So, y equal to minus 4 plus minus 8. So, this is going to give us 2 points. One is 4, the other is minus 12. So, that means this intersection has to be 4. But will it be exactly this intersection or not, that we have to verify with the circle. Okay. So, for that we just put this point in the circle and see what happens. If y is equal to 4 and if I put y equal to 4, I will get x to be 2. So, x equal to 2 and y equal to 4, I am verifying if this point satisfies or not. So, if I put it, what do I get in the circle? So, 2 square plus 4 minus 3 whole square, and this is going to be 4 plus 1 square. This is definitely less than 9. So, this point is still in the interior of the circle. So, that means our intersection is going to be somewhere here. This is the parabola. Okay. So, it is a much wider parabola. Now, what is the area that we are talking about? Area must be interior of the circle, it must be below the line, and also it must be inside the parabola. So, what is the common portion here that we are getting? Common portion is this that we are getting. Okay. Now, we want to solve this question. So, how do we solve this question? So, here y square is less than equal to 8x, that is right. Okay. So, how do we find this area? To find this area, here the area is little bit complicated because there are so many diagrams involved and they are actually confusing you even further. So, to solve this question, what we will try to do is, we will try to first decide whether we are going to integrate this with respect to x or with respect to y. But either way it is going to be even confusing because there are 3 boundaries involved here, and even if we go for integral with respect to x, we will break the integral here, but then there is a confusion about till what part we should be taking. But if we go for integral with respect to y also, there is a slight confusion, but we can still execute it. It may take little bit more time, that is it. The other way could be like this. Other way could be to find this area and subtract it from the triangle, but then again it is going to be another headache. So, what we will try to do is, we will take only this part. Okay. So, just look at this diagram, how it is looking like. Okay, so this is how the diagram is. This is the straight line part, this is the parabola part, and this is the circle part. So if I just integrate it till here, that means if I take this as curve 1, this is curve 1, this is curve 2, this is curve 3, sorry. This is curve 3, this is curve 2. And from this point to this point, this is 0, and this point we have already calculated, this is going to be 2, 4. Okay. So from 0 to 2, when we are integrating, what we will do is we will take curve 3 minus curve 2 dx plus from here to here, that means till here. So we need to also find this point of intersection. So from 2 to this value, we will be doing C1 minus C2 dx. This way we can get the required area. Now how do we find this value? We find this value by solving for the point of intersection of line and circle. So again we need little more rough work. Okay. So that we will do in the next page. X square plus y minus 3 whole square is equal to 9 and x plus y is equal to 6 is the line. Now let us try to solve this. So I will substitute for x here, so that will give me 6 minus y. So 6 minus y whole square plus y minus 3 whole square, this must be equal to 9. So when I simplify this, I will get 2y square, here minus 6y, here minus 12y, minus 18y, 36 plus 9, so 9 is getting cancelled, plus 36, this must be 0. Now if I further simplify this, I am getting y square minus 9y plus 18 is equal to 0. So 6 into 3, so y minus 3 into y minus 6 equal to 0. So what is this point of intersection? This is going to be 3, 3. Okay. So that means the next, this value limit is going to be 3. So this way we can complete the process. Now let us execute this. What is the C3 here? This is our C3, which is the parabola. And what is the C2? C2 is the circle. And what is the C1? C1 is the line. Okay. So let us execute this process. So area is equal to integral of 0 to 2. What do we have to do? We have to do C3 minus C2. C3 is the parabola. If y square is equal to 8x, so y will become root of 8x. So we have to put 2 root 2 x here, root x minus, what is the equation of the circle? So the circle is this equation. So from here, if I get y minus 3 whole square, it will be 9 minus x square. So y is equal to 3 plus minus root of 9 minus x square. But out of these two, which should be taken? Which should be taken? So here if we observe, till here, it is the lower part. If we divide this circle into two parts, this is the center and this is the center which is having y coordinate as 3. So all the values, all the points which are below this line shall be having y coordinate less than 3. So it must be having 3 minus sign. So for C2, when we are taking for the integral, it must be taken as 3 minus root of 9 minus x square. Okay. So that means here we will be writing 3 minus root of 9 minus x square into dx. This is our first integral. Next, 2 to 3, again here we have to do line minus circle, and what's going to be line? Line is going to be 6 minus x and again minus 3 plus root of 9 minus x square dx. Okay. So now here we can simplify it further or we can directly integrate, it does not matter. Okay. So now I'll just simplify this little bit more. So here I'm going to get 2 root 2 root x integral 0 to 2 dx, and there is minus 3 here and there is 6 minus okay. So minus 3 dx. This is going from 0 to 2 and here it is going from 2 to 3. So, I can directly say 0 to 3. Again plus root of 9 minus x square integral going from 0 to 3 dx, because it is going to be covered in both the integrals. And again there is one more term that I have just missed, which is the 6 minus x, that I will put here, integral 0 2 to 3 6 minus x dx. What I did is I tried to combine the limits if possible. Okay. So, now we just have to integrate this. Okay. So, how do you proceed? Here it is going to be 2 root 2 into x root x by 3 by 2 going from 0 to 2. Here 3 into 3 minus 0, and here you already know this type of integrals. Okay. So, basically 0 to 3 root of 9 minus x square, this looks like circular integral. So, this is like circular integral taken in only one side. Okay. So, this is going to be 1/4 of the area of the circle. For example, if you still do not have any clarity, let me explain this here. Okay. If I am taking y equal to root of 9 minus x square, okay. So, this is going to be a curve like x square plus y square equal to 9. So, which means there is a circle here which is having radius as 3 units, having center at origin, and if I am integrating 0 to 3 root of 9 minus x square dx. So, what is the area that I am actually calculating? I am actually calculating this area. Okay. So, it is 1/4 of the area of the circle. So, I can straight away write here that pi into 3 square by 4. See, with help of geometry sometimes we can also integrate integrals. Okay. But if you go for the integration, it will be the same. Okay. And again here 6 into x, and when I put limits it becomes 3 minus 2, and again here it becomes x square by 2. So, 1 by 2 into 3 square minus 2 square, that is it. This is going to give us the values. So, what will be the integral here? So, it is 4 root 2 into 2 root 2 minus 9 plus 9 pi by 4, and here it is plus 6, and here it is going to be minus 5 by 2. So, if you simplify this, you will get the required value. So, that way we can find the integral. Okay. So, now here the integral has become little complicated because the diagram is complicated, but these kind of questions are common. Okay. They keep coming in at least one of the advanced papers that you practice also. So, in advanced papers generally, if there is any question on area under curve, it is going to be as complicated as this in terms of the diagram, but in terms of the integral, of course it will be very easy. That is what the people who set the IIT papers think about. They make it conceptually tricky and conceptually confusing, but algebraically simplifying. They always do that. Okay. So, here accidentally algebra has become long, but algebra will not be that long in general. Okay. Come on, make a note of this. This page also. This page also, and this page. So, it has become a habit for me to take some pages for rough work also. Okay. So, that is why I am also taking too many pages. It may look like that, it may look in such a way that I have been solving questions in a very lengthy manner. No, it is not like that, because my writing style is big, because the letters that I am writing is big, it looks lengthy to you. So, some teachers may provide this entire solution within one single page, but for the visibility of the students, I increased my font size and I have been writing this big letters. Okay. Now, there is one more question, which is find the area of the curve enclosed by the curve. So, how do we do this? In fact, if you check, this curve is going to be an ellipse. So, this curve is going to be an ellipse. So, if I try to find the major axis and minor axis of this ellipse directly, then I can find the area also directly. So, we can do that by converting the entire question into coordinate geometry, but that is going to be long question. But if we try to do this by converting this into a quadratic form, it is going to be another method that could be easy for you. But here I am going to discuss both of them. Okay. So, first is, suppose let us say we want to solve this in coordinate style. Okay. By the way, my job here is not to impress you with shortcuts, my job here is to teach you the techniques and to develop your skills. So, I am going to teach all methods, whether they are lengthy or easy, I am going to teach all methods, and it will be good if you learn all methods. These methods may help you in at some point or the other. Okay. So, let us say this is general ellipse and we want to handle this ellipse. So, how do we handle? Our first step is to go for the center. Okay. So, how do we calculate center? By going for the partial derivatives. So, if I differentiate this with respect to x, only x, partial derivative I am talking about. So, I will get 10x here plus 6y plus 7 equal to 0. And now I will differentiate partially with respect to y also. So, if I differentiate this with respect to y partially, I will get 6x plus 4y plus 6 is equal to 0. Now, we want to solve these two. So, how do we solve? We can eliminate one of the variables. So, let us say I want to eliminate y here. So, I will multiply this with 2, I will multiply this with 3 and subtract. So, here when we subtract 20 minus 18, it becomes 2x and this y terms will get cancelled. 14 minus 18, it is going to be minus 4 is equal to 0. So, which means x is equal to 2. If I put x equal to 2, so what am I getting here? 3 into 2 plus 2y plus 3 is equal to 0. So, this is going to be 9. So, y is going to be minus 9 by 2. So, this is the center. Now, center I will just write it here, it is going to be 2 comma minus 9 by 2. So, that means we got the center. About the center, if I try to convert this question, sorry. Now, if I shift the origin to the center, then equation of the curve will look like this: 5x square plus 6xy plus 2y square plus constant k is equal to 0. If I shift the origin to the center of the curve may look like this. That means the new center of this curve is going to be origin. But how do we find the value of k? Value of k we get when we substitute this point in the equation. So, let us just evaluate this k. So, k is going to be 5 into 2 square plus 6 into 2 into minus 9 by 2. So, this is going to be little longer method. So, I will not solve this completely. I will assume that you will get it, and that is the k. Now, what is the idea? We are interested in finding out the major axis and the minor axis. Basically, we are interested in finding out 2a and 2b or a and b. If we get a and b, then pi ab will be the area of the ellipse. So, how do we get a and b? For that, I have discussed one technique in ellipse. So, what do we do here? We take this curve 5x square plus 6xy plus 2y square plus constant k is equal to 0. We take this curve and we put x equal to r cos theta, y equal to r sin theta. and then we try to generate an expression for r. So, here r square will be equal to minus k divided by 5 cos square theta plus 6 cos theta sin theta plus 2 sin square theta. Now, this is in terms of trigonometry. If you can calculate r maximum, that will be the semi-major axis. If you can calculate r minimum, that will be the semi-minor axis. Okay. Now, how do we calculate r maximum, r minimum? These ideas I have discussed in ellipse already. So, when you put it here and when you try to maximize this value, for a particular value of theta, you may get the maximum and minimum values. Okay. So, now after you get A and B, the area will become pi AB. Okay. This is the coordinate way. So, I have discussed the entire method here. Okay. So, what is the main idea? First step is to get the center. Next, second step is to convert the equation into this form by shifting the origin to the center of the curve. And after we get the equation of this curve, here this k can be obtained by substituting the coordinates of the center in this equation directly. Now, after we get this, directly go for the x equal to r cos theta, y equal to r sin theta substitution, find r maximum, r minimum, those will be the semi-major and semi-minor axis, and then you can find the area. Now, let me explain you using the other idea, which is the quadratic way. Okay, quadratic way. So, let us take this equation 5x square plus 6xy plus 2y square plus 7x 6y 6 7x plus 6y plus 6. Now, here by taking any one variable as my primary variable, I will try to complete the square here. So, I will take y as my primary variable. So, to convert this into a perfect square, I will write this as 4y square, I am taking all y terms, plus 12xy, I am also multiplying with 2, of course you might have noticed, plus 12y, plus 10x square, plus 14x, plus 12. Now, here we can write this as 2y whole square plus 2 into 2y into 3x plus 3, right. So, to complete the square here, we have to provide one 3x plus 3 whole square, and that means in the RHS we are going to get 10x square plus 14x plus 12. So, basically I am using completing square method. This is going to give us few expressions, you will just see. Okay. So, plus 9x square plus 9 plus 18x, okay, right. Any confusions here? Okay, so here these must be minus signs because I have taken these terms to RHS. Okay. So, here I am basically getting something like minus x square and plus 4x minus 3. So, this is going to be minus x minus 1 into x minus 3, that is right. And here LHS is going to be 2y plus 3x plus 3 whole square. So, this is going to give us 2y equal to minus 3x plus 3 plus minus root of 3 minus x into x minus 1. So, I have written it this way. So, we directly got an expression for y using completing square method, or using quadratic formula also you will get the same thing. You can also apply the quadratic formula, but the algebra is going to be same there also. Now, this means for this y to be real, the value under square root must be non-negative. So, x must be belonging to 1, 2, 3. So, whatever is the ellipse that we are going to get, it has to be between 1 and 3 only. Okay, it has to be between 1 and 3 only. So ellipse may be of this shape or maybe it could be of another shape, we don't care. So from here to here, if we get one expression of y, it's going to be the above curve is going to be with the plus sign and the below curve is going to be with the minus sign. Okay. So if I take this curve as C1 and this curve as C2, above curve will have plus sign here, below curve will have minus sign here. Now we are interested in finding this entire area. So how do we do that? Integral 1 to 3 C1 minus C2 dx. This is going to give us the area. Okay. So how do we find the difference of this? That we can directly observe here. So if I put plus, there is one, if I put minus, there is another, and if I take the difference, what do I get? So let me just explain them, both of them to you. So here y1 is going to be minus 3x plus 3 by 2 plus under root of this divided by 2, and y2 is going to be minus 3x plus 3 divided by 2 minus under root of this by 2. Now when I take the difference, what will I be left with? I will be left with only the square root term, that is also coming in double times, and there is 2 here in the denominator. So the integral is going to be somewhat like 1 to 3 root of 3 minus x into x minus 1 dx. That is it, only this much is the part. So algebraically we can also do it this way. Now how to integrate this? This is one of the standard integrals. We have to substitute x equal to 1 into cos square theta plus 3 into sin square theta and simplify this integral, and you know how to perform this integral. Okay. So this calculation part that I am leaving it to you, you can complete this integral and find the area. Okay. So this way we can also solve this problem using quadratic and algebra. Okay. Come on, make a note of these ideas. This page also. Also this one. Also this page. Okay. Now we will proceed to the next concept that I was talking about. So I am confident that you can complete this integral just by using this substitution. Okay. Can we proceed? So now we will go for the other applications, which are basically the arc length and surface area and volume. So how do we find arc length of any curve? If it is a circular arc, we know how to find that. R into theta, theta is in radians, that will give you the arc length. But if it is a random curve, let us say it is an ellipse, you want to find the arc length of ellipse, or you want to find the arc length of parabola. So how do we do that? For that, here is the idea. Let us take a curve here. So let us say I have taken a curve here and I have taken one small strip. Okay. See, these ideas may come in physics also. So that is why I am going to explain these problems and these ideas just like the way you solve questions of physics. Okay. So in physics, most of the time we take small strip. Okay. So let me take a small strip here, and what will be the thickness of that small strip? Thickness is going to be dx. What is the meaning of dx? Dx is the change in x. Now this is the thickness, and if this distance from y axis is, let us say, x, then this height is going to be f of x, right. So that means, let us say if I take this part and magnify this. Okay. So let me explain that little while later. So if I take this vertical strip, what will be the area of that vertical strip? It will be f of x into dx, you already know that. So when we take f of x into dx and integrate it, let us say from a to b, so we are going to get area, right. This is what we have learned in the area part. Now when it comes to the arc length, we have to zoom it and observe there at the point of contact and see if we are actually getting the arc length or if it is actually parallel to x-axis or not. Because curve is never parallel to x-axis, if we zoom it there, we are going to get something like this. So, this is the area that we have just derived here using this formula. Okay. So, or we can just say that because this is a small strip, so the area of this is f of x into dx. Now, to get this arc length, what we will try to do is, we will try to form this line segment. Basically, this is the chord which is joining these 2 points. Now, if my dx is very small, if dx is tending to 0, this arc length and this chord length both will be equal because arc becomes chord there. And we know that this is the small change in x, which is dx. We know that this is small change in y, which is dy. So, we can say that this length is going to be root of dx whole square plus root of dy whole square, right. So, that is the minute arc length for that small element dx. So, that means if I integrate this from a to b, I will get the arc length of the entire curve from a to b. So, from a to b, root of dx square plus root of dy square whole integral will give us the arc length. But with respect to what we are integrating this, that will depend on what you are interested in. If you want to integrate that with respect to x, so then take dx common. So, from here if I take dx common, this will give me root of 1 plus dy by dx whole square into dx is outside. So, dy by dx is nothing but f dash of x. So, it is root of 1 plus f dash of x whole square into dx, that is going to give us the arc length. Okay. This is the main idea of arc length. Now, using this we can also prove arc length of any curve. Okay. So, here the major part that you need to understand is basically this part. When we take small strips like this, basically we are taking the areas of rectangles, but still there is some minute gap which is left out at the top of the rectangle, that I have taken, I zoomed it and I observed the arc length and then I wrote a formula. You can also generate your own ideas based on these concepts. In fact, if you have conceptual clarity, you can crack any problem. Okay. Come on, make a note of this. Okay. Next problem, next idea. Suppose let us say I want to find surface area by revolution, by rotating. So, suppose let us say I have taken a curve like this. Okay. So, basically I have taken curve like this here and this is my x axis. So, if I take any strip here, okay, if I take any strip here, small strip which is going to be dx, what will be the height of this strip? Because from y axis I am taking the distance to be x. So, the height is going to be f of x, which is also same as y. Now, when I rotate this curve, I am going to get a surface like this. But now ignore the curve and just rotate this minute rectangle that I have taken. If I rotate this rectangle about x axis is the axis of revolution. So, if I rotate this about x axis, I am going to get one circular disc. Now, what will be the area of that circular disc? Pi y square. What will be the perimeter of that circular disc? It will be 2 pi y. Okay. So, perimeter is going to be 2 pi y, area is going to be pi y square. So, let me first take the perimeter. Perimeter is going to be 2 pi y, right. So, that means basically I am taking one disc like this. Okay. So, now imagine that disc is somewhat like this, it is not exactly circular disc, because that means the curvature is not exactly vertical here. So, we could get the perimeter as 2 pi y, but because this is not exactly parallel to x axis, because this curvature is not exactly parallel to x-axis, this is not parallel to x-axis, we have to multiply this with the arc length and integrate it to get the surface area. Basically, we are interested in finding the surface area. Okay. So, how do we find the surface area of this disc? Basically, we are interested in this area. So, how do we find this area? By taking this measurement and also this measurement. Okay. So, this is the 2 pi y, and what about this length? This is going to be the arc length. Okay. So, we are going to multiply these two dimensions to get the surface area. So, that way we can say that 2 pi y into arc length integral of this is going to give us the area of the curved surface. Okay. So, this has to be curved surface. And similarly, if I take dx whole square common, this will be the formula for the surface area. Okay. Come on, make a note of this also. Okay. Now, let us go for the volume. So, let us say I have taken one curve here which is y equal to f of x, and if I take one small strip here, this is going to be dx and this length is going to be x and this height is going to be y, which is also same as f of x. So, what will be the area of this disc when I rotate this? When I rotate it about x-axis, it is going to be like this. So, the disc is going to be somewhat like this. There will be a disc here. Okay. Now, the area of that disc is going to be pi y square, and into dx if I do and if I integrate, this is going to give me the volume. Okay. So, basically this disc is being varied from a to b in this direction. So, basically I am going to do pi y square into dx, that will give me the volume. Okay. So, here we have understood the basic concepts of arc length and surface area and also the volume. Okay. So, based on these ideas, we will solve some problems in the next lecture. I will stop at this point. I hope you have enjoyed these techniques and these ideas. We will meet again in the next lecture with more exciting problems. Until then, have a great learning day. Learning shall never stop.